Hi, so today we're going to go over 2.7, which is mixture applications, and we're going to take a look at these types of problems. So in all of these application problems, a lot of the equations that you use are going to be really similar to one another. And it's just that process that you have to find in each one. Look at the clues and then see which type of equation you're going to use. Is it a system of linear equations? Is it a percentage problem? That kind of thing. Now, a lot of them are going to use this over here, this distance equals rate times time. So that's a good thing to remember because it'll come up in a bunch of different problems. Another thing is that if you have an original amount and then they give you the percentage of something in the original. So let's say you had some solution and they're telling you the percent, there's 5% of that original solution is salt. Then if you multiply the amount of the original times the percent in decimal form, you'll get the amount of that thing that is acting on the percent. So the amount of the solution times the percent salt will give you the amount of salt in the solution. So those are some good things to remember. So now let's take a look at question number 9. Question number 9 says, a long-distance runner starts at the beginning of a trail and runs at the rate of 6 miles per hour. 1 hour later, a cyclist starts at the beginning of the trail and travels at a rate of 14 miles per hour. What is the amount of time that the cyclist travels before overtaking the runner? So this is a little bit of a complicated problem. So let's start out just drawing a picture for it. We know that the runner starts here and travels for 1 hour at 6 miles per hour. Okay, so this is the beginning of the trail. So let's say she gets here, that's 6 miles. So she's traveling 6 miles because she takes 1 hour to get there. So now the runner is right here and the biker is still back here. Now the biker starts out, so they start out 6 miles apart, and the biker is traveling at 14 miles per hour. Now the runner is still traveling at 6 miles per hour. She just had a head start. So we can take a look at this distance equals rate times time and use that to find the answer. So we don't know the amount of time it takes for the biker to catch up to the runner, but let's call that T. So T is the amount of time it takes for the biker to catch up to the runner. Now, we know that they start out 6 miles apart, but they're going to be a little bit more apart because the runner is still running. So let's see if in T amount of time, the runner is going to run, distance equals rate times time. The rate is 6 miles per hour, so 6 times t is the distance that the runner is going to run, because distance equals rate times time. So the extra amount the runner is going to run in the time it takes for the biker to catch up is 6t, or t times 6. So in total, our distance is going to be 6, the original number of miles they are apart, plus 6t, the number of miles that the runner runs before the biker catches up. So that's our total distance that the biker needs to go to catch up to the runner. Now we know the biker's rate is 14 miles per hour. So using the same equation, the distance equals rate times time, we can solve for time. So we know distance, which is our 6 plus 6t, equals rate, which is our 14 miles per hour, times time, which is our t. So we get this equation. 6 plus 6t equals 14t. So you can solve this by first subtracting the 6t over to the other side. So you have 6 equals 8t. And then to solve for t is being multiplied by 8, so we have to divide both sides by 8 to get our value for t. So t is 6 over 8, or 0.75. Now we want to look back at what this means. So t was time, and t was the time that it took for the biker to catch up to the runner. So that's our answer, so in hours. So that's one of those questions, number 9, that's a little tricky, and it's really helpful to draw a picture for some of these problems if you're having troubles with them. Now, I'm going to post some solutions for some of the other problems on the discussion forum, but make sure that if you have any trouble on any of these problems, just take a screenshot and post it on the discussion forum, and we can work through it on there. Thank you.